Let's practice distance tree using SPSS more. Please download this file, Riding Modes Amended. The original source is data mining for business analytics, but I changed the variable types. There are many questions to answer, and the questions are very similar to the question in the assignment. If I take a look at them briefly, first you are required to do a univariate analysis, bivariate analysis using cross-tabulation, and then decision tree model setup, conduct the decision tree analysis, interpret the tree as we did in the previous video, save some new variables, and then once we get the predicted values, we compare the actual y variable and the predicted variable and evaluate the model prediction accuracy. As a conclusion, I ask you to choose which segment you are going to target based on the types of consumers. There are two types, consumers similar to the current owners versus consumers similar to the current non-owners. So depending on the consumer types, you should be able to provide the reasons why you want to target a certain customer group. Once you select or target a segment, you should be able to develop marketing strategies to increase sales in terms of product, price, place, and promotion. So these are the questions in the Word document. I'll briefly show you how to do like a univariate analysis and bivariate analysis using SPSS, and then I will mainly focus on distance tree analysis. Before we take a look at the data, let's take a look at the questions one more time. Conduct univariate analysis for all the variables, and then make cross tabulations using the discrete variables. Y variable is ownership, and X variables are income and lot size. If you see the file, you can find household ID 1 through 24. Still, the number of observation is very small, but as a practice, it is very useful. Our Y variable is ownership, owner versus non-owner. We have income level, lot size level. In fact, in the original file, there are continuous variables like continuous income and continuous lot size, but I transformed them into income group and lot size group. To understand the meanings of the values 1 through 3, click on variable view and then income and lot size. You can see the values like this. So if you click one of them, you can see that 1 means low, 2 means middle, and 3 means high. Because the variable is categorical variable, we can see that income and lot size are not continuous variables but discrete variables. So simply they are all discrete variables, and to examine the relationship later we will use cross tabulation and decision tree. But before we do any advanced analysis, we need to take a look at them one by one, which is called univariate analysis. So let's click on Analyze Descriptive Statistics, and in this case, frequencies. The reason is, again, ownership, income, and lot size groups are all discrete. So move them to variables, and then run OK. Basically, out of 24 consumers, 12 consumers own riding mowers, while the rest of them, another group, owned riding mowers. and you can find the income levels and lot size levels as well. Now, let's assume that you are interested in the relationship between ownership and income, ownership and lot size. Because the variables are discrete, we are going to do cross tabulations. Click on Analyze first, and then Descriptive Statistics and cross tabs. Please note that ownership, the Y variable, needs to go to column, and then X variables are income level and lot size levels. So move them to row, and don't forget to select row percentages. Continue, and OK. Then you can see the table, cross tabulation, and why don't you try to interpret each cross tabulation by yourself, especially row by row, as we practice in other videos. The second question, a marketing analyst, that is you, is interested in segmenting the customers in terms of income and lot size, that means they are axis, to understand the ownership decision. That means this is the Y variable. Create a conceptual model. It is important. We already practiced, but before you start any analysis, it is recommended creating or setting a conceptual model. And then check whether the types of variables are appropriate for a decision tree. So it is simple. Our Y variable is ownership. Our X variables are income group, and then lot size. There would be many ways to see the relationship between X variables and the Y variable. But as we checked with the SPSS file, ownership is discrete, income group discrete, size discrete. So according to our analysis classification table, we can try decision tree. Especially we want to incorporate all the X variables. So instead of cross tabulations, a decision tree model would be better. Then number 3, conduct a decision tree analysis. Again, Y variable ownership, X variables are these two. Remember, CRT is our growing method. In the output tab, you need to choose importance to model option and criteria growth limits. Again, because we do not have many observations, we need to lower the numbers to have like a bigger tree. So let's practice this like SPSS procedure. So analyze. Based on our conceptual model, we want to do a decision tree model. So analyze, classify, and tree. Then our dependent variable is ownership. So click this one and move. And our X variables are income and lot size. Please do not use household income, income 2, or lot size 2. We just need to use these 3. Growing method, CRT to get the importance to model table. Once you click on CRT, go to output, and then go to statistics, and in this box, independent variables, click on importance to model and continue. Before you run the model, make sure that you click on criteria. And again, because we have only 24 observations, we need to kind of change the numbers here. So maximum tree depth, maximum 3. minimum number of cases in the parent node, let's say 5, in the child node, 2 or 3, does not matter much, and then continue. And then press OK. Now you have this kind of tree. And later I will ask you to interpret the tree, but before we do, let's check another model with different parameters. For example, let's say you do not need to do this, but let's say I just used like a maximum tree depth automatic, and I did not change the numbers here. Again, you do not need to do it. Then nothing shows up. If I change the numbers, like a custom value 3, and I'm going to change this one to like 10 and 5. So customization, and I minimize the number of cases in each node. And then I have very simple tree compared to this kind of detailed tree. So it is better to find like a right size tree, and later I will explain more, but we already learned the terminal node or nodes or segments. So in this case, 1, 2, 3, 4. There are 4 terminal nodes. So you'd better have terminal nodes, like about 6 to 7 terminal nodes to have a right size decision tree. In the Word document, I ask you to interpret the tree. So special questions are: how many terminal nodes segments does the tree have? What are the ownership percentages of each segment, especially the terminal nodes, compared to the total ownership percent? Describe the splitting rules, and then figure out which variables are more important. Let's answer one by one. First, terminal nodes. I already explained. I would better copy and paste the text. Let's take a look at the questions one more time. How many terminal nodes? So here, this is the root node, and it's further split into node 1 and 2. By the way, after node 1, no other like a child node, so this is the terminal node. Node 2 is further split into node 3 and 4. After node 3, nothing is attached, so this is the terminal node, and node 4 is not the terminal node, but node 5 and node 6. So we can find that there are 4 terminal nodes in this decision tree, and depending on your settings, you will have different numbers. The second question is ownership percentages. Out of 24, we know that 50% of them own riding mowers, but in the node 1, 100%. 100% out of 5. In node 3, out of 3, 100%. Node 5 out of 12, 33, which is lower than the total percentage. In node 6, 0. None of them purchased riding mowers. So we can see, kind of summarize that in node 1 and 2, there are more. Actually, all of them are owners or people who are likely to purchase riding mowers, while in node 5 and 6, fewer people purchased riding mowers, or people are less likely to purchase mowers. So different kind of segments. Then who are they? To understand the characteristics of each segment, we need to use this splitting decision rules. For example, in case of node 1, their income level is high, like high level income customers. So identified. Node 3 or segment 3, their income level is low because they come from node 2. So income level is low or middle, and lot size is high. That means regardless, even though their income level is not high, if their lot size is like too high or large, then people purchased lawn mowers. Then how about other segments? Income level, low or middle. Lot size, low or middle. So because they fall into this path. And then lot size, again, we will use lot size again. Middle, in this case, 33% of them purchased the product. But if lot size is low, 0. So as a conclusion, income level is lower or middle, and lot size is middle or low, then people are less likely to purchase lawn mowers. Therefore, it turns out that income and lot size affects ownership, and results are kind of intuitive. Last one, which variable is more important? So we kind of split our entire group in terms of income level and then lot size to know which group or segment is more likely or less likely to purchase lawn mowers. Then to kind of split our or classify our consumers into a small number of groups, what variables are important? To understand that, we need to look at this one. So independent variable importance table. So it seems that lot size is a little bit more important than income, but overall, when you look at normalized importance, they are almost similar. But lot size is a little bit more important.